right. Awesome. So it's nice to see the session being very interactive. Let's keep it that way. Up next, we have the first external speaker of the day. We have Raghuram Sripada from Hitachi Vantara. So just a brief about Raghu, right? So Raghu has been a very seasoned and experienced leader with 25 plus years of experience. That's almost just less than my age. So I'm really humbled and glad to have a speaker of such stature here. And his experience has kind of helped him in having deep understanding in different domains. He has worked on SaaS, PaaS, data infrastructure, etc. And he has also driven impact across companies, right? So Hitachi, Oracle, Salesforce, and so on. And the best part is he's also a keen advocate of best practices in inner source and open source. So really excited to listen to this talk.
Sure. Thank you very much. So let me switch to, yeah, that's me. So maybe just to expand on the introduction. So I joined Hitachi like 1.5 years ago, slightly over 1.5 years ago. So I joined Hitachi to build their SaaS common services. So however, I was asked to do something else. So 2 months, 3 months into my job. So I'll get into that. So before joining Hitachi, I was at Salesforce for 7.5 years. It was more of a SaaS world. And then before that, at Oracle, where I worked on Oracle's OCA, the very first versions of OCA. I was a product manager there. So I was pampered by the cloud world. And so where you have elasticity, you don't need to worry about constrained environments, where you don't need to worry about, say, the number of CPUs or GPUs are available. So now the recent problem for me has been balancing both. So at Hitachi, we are a hybrid company. So this is where what we do. Hitachi is a large $80 billion company. Out of that, Hitachi Vantara is into data infrastructure. It's basically storage and then the converged systems. These are used in data centers by customers. There are use cases where customers want to run their workloads in air-gapped environments, the sensitive customers. It may be financial services or public sector. And then you also have a lot of sensitive use cases where you don't want to send the data outside your environments. That is where our customers use it. And then Hitachi, as a larger group, is also a major customer for us. Hitachi is into various industrial systems, including power plants, nuclear power plants, etc. So the railway systems and all. So we also provide what are known as converged infrastructure. Converged infrastructure has storage. You have CPUs, GPUs, high-speed networks connecting all of them and bundled in a single box, right, or a set of boxes. That is the business we are in. And then to manage this entire thing, we build software. So that is the business that we are in. Then these are really designed for mission critical applications, most of them. Again, the compliance requirements are very high. And then when I say pampered by cloud, these are all constrained environments. You can't, you don't get elasticity, right? So how do you optimize the software stack on that? That itself is an issue. And then deployment. Our software stack works in hybrid environments. It works on-prem, and then we also have some layers that operate on the cloud. So there are certain use cases for which it suits. Then we also have this requirement. One is the ability to run completely on-prem with a choice to also use the cloud services. That is the typical requirement. Now coming to the journey, right? So this session is about the journey. So I joined sometime in February, March. So in June, that's where everyone was talking about ChatGPT, and then our bosses were attending conferences. They were seeing these nice demos, and then they want us to build similar GenAI applications. So then we also got into an alliance with NVIDIA. So jointly, we were designing some products, the converged infrastructure, where we are bringing their GPUs and then our storage network, and then launching a new product. It's known as Hitachi IQ. It was announced last year. So it bundles GPUs like H100s and 200s, and then along with that, the software layer goes. So the mission that was given to me was to create a GenAI platform. The very first condition is that you should have any vendor lock-in or CSP lock-in. So you should not use OpenAI. you should not use Anthropic, right? Because these are air-gapped environments. I need to run my entire system using open source LLMs. Remember, 1 year ago, the LLMs were not as mature as today, right? We have a lot of capabilities. You have a lot of innovations like mixture of experts, etc., and then a lot of capabilities built into the LLMs. So that's when we started. And then how do we empower users to build GenAI applications? GenAI applications, most of us, we saw more the chat interface, but there are various other applications. For example, an event generated, and then you consume that event, and then you use GenAI as part of the orchestration. That may be a possibility, right? So how do we help anyone to quickly develop applications? So basically, time to value. How do we deliver that? And then we need to use existing foundational cloud native services. So Hitachi has a very interesting history. They built their own HKS, Hitachi's own Kubernetes service. Kalyan was leading that. I actually inherited that team. So how do we use those services? So we built, for example, the event notification service or multi-tenant authentication and authorization service. We need to use that so that we get returns on the investments that we have already made. And then we also need to quickly provide access to both structured and unstructured data. That is another one. And then finally, to quickly develop applications, if you provide templates, users can quickly convert that into the usable applications. How do we do that? So again, creating some templates so that users can use it. For example, a Copilot template using which users can quickly replicate that and then expand that. That is the other one. And then finally, we are very passionate about sustainability. So Hitachi has been a leader, by far the leader in sustainable infrastructure. So as part of that, we continuously drive optimization. One of the drivers for that, one of the initiatives is to take up Rust. So we need to prioritize Rust as much as possible. So these are all the constraints using which I was supposed to develop a GenAI application. So I inherited a team of experts who mastered Kubernetes. Okay, so I had 2 data scientists and I had 1 ML ops engineer. That's it. So with them, I need to build this. So that was a challenge. So I had to quickly put them on various practice sessions. We started building GenAI applications. At that time, I didn't have even my on-prem environment. We were on Azure. So we were using Azure and then Azure GPUs, burning a lot of dollars. So then we ordered our GPUs and then we started setting up our environment. So we did that. Now, again, we were pampered. Right? So there is elasticity. Now I have 4 A100, which we got with great difficulty. So we had to pull strings to quickly deliver those. On-prem, it was not easy. Last year, they were in demand. So we finally, after 2 months, we set up our environment. Then we started getting into replicating what we were using on the cloud. So when we were running it on Azure, part of our demos were using still OpenAI API endpoints, but we should not use it, right? So that's where we started building. So we learned a lot of lessons. We started with Alpaca. We wasted some cycles in fine-tuning some of the old models. Again, that is also learning. So though we lost cycles, it was a learning. Then we started reading a lot of papers. In fact, the team was literally living on Arxiv. So everyone goes and then reads papers. So that was an amazing experience. But we started building that and we found some patterns. So let me start with that. This is where the actual presentation starts. So if you look at a simple GenAI app, so let us start with a simple chat interface. There is a user sends a query. The query is really converted into a prompt. So prompts change based on LLM, the templates may be different. So it is sent. Once it is sent, there is an orchestration step. In that, you do what's known as semantic search. So semantic search can happen on various stores. So the most common is your vector databases. You have different search techniques, semantic search techniques. And then there is also another approach where you put part of your metadata on knowledge graphs, and then you use both. So there is one semantic search. And then to serve this request, you may need some data. So that's where you get data from various data sources. It may be your structured data sources like databases or applications, etc., or it can be your unstructured data. So unstructured data can be in different formats. It may be in PDFs, it may be images, right? So it may be some of the tickets you may have, especially in the hardware world. So there may be some diagrams, right? All of them are the sources. And then you may be also making API calls. It is a very important part. So for example, you want to know the current state of your system, you may have to make an API call. So this is what you do, and then you get all of the data, add to your prompt, and then send it to LLM. LLM uses this entire thing and then sends back the response. It generates the response. So now if you really look at this, there's sort of a pattern, right? So pattern is you have query, you have context, and then you also have examples. Examples is basically you're telling, so what kind of output you are expecting. When you are giving examples, LLMs do better, right? So that is where we talk about few shot prompting. So then as part of building this, we acquired a lot of knowledge about prompting techniques. We acquired knowledge about how to get context, how to store context. To get the context, first of all, you need to store. That's where you need to build the data pipelines. So then once we started doing this, what are we doing? We're building a platform. So we need to give it to our customers. Our customers are internal product teams, and also later to our larger customers. We need to first eat our dog food, right? So that's where we started looking at these questions. How do we empower everyone to develop GenAI apps? We are developers. We are writing code, it's good. And then we are cloning something on GitHub, and then we are expanding on that. That's good. But what about the actual business users in the different lines of businesses? Then how do we provide the ability to customize the orchestration? This part is a key part of any GenAI app. You need to get the data from various sources, metadata from various sources, and do that. How do we make it very easy to optimize that? And how do we enable access to the data? You need to get data from various sources. How do you do that? And then how do we make it easy to create the data pipelines? So to make it simple, I'm calling it creating indexes and knowledge graphs. It's nothing but data pipeline. And then finally, how do we serve multiple models? This is one of the major problems. So you have various models. We also use some ML models for certain use cases, and you have different LLM models. There are some large ones and there are small ones. So for certain functionality, you may want to a specific model. How do you serve different models? So using the infrastructure. Again, please remember, we have constrained environment where we have limited number of GPUs. We have to optimize the GPU utilization. That also we need to do. How do we serve that? So if I convert that into functionality. So each of these areas that I spoke about. So for example, let us start with data pipelines. So how do we take data from various sources? Maybe unstructured data. How do we create chunks? There are various chunking strategies. You need to, every application requires a different chunking strategy. There is no single strategy. So you will have to learn, you will have to experiment, you will have to evaluate, and then only you find the right option. How do we do that? And then how do we index? How do we put that in vector databases? Again, when you store in vector databases, there are again various techniques. How much of metadata you want to put it, or how you want to create these the embeddings, and then there are various embedding models. I should give my users the ability to switch between embedding models also. For example, today E5 may be better, and tomorrow maybe MGE is better, so BGM may be better. So they continuously evolve, right? I need to give that ability. And then knowledge graph creation. Graph rag is one of the techniques which is becoming very popular. For that, you need to take the documents, you need to create knowledge graphs out of that. That itself is a very interesting problem, right? How do we do that? That is one problem. And then the next one is, how do we provide unified access to all kinds of data, structured and unstructured? That is another functionality. And then orchestration. How do I allow the developers with very little effort change the orchestration process? Right? That is another step. So it has various capabilities. Agentic RAG has become very popular, and then there is a concept of tools. So that is another one. How do I provide that? And then finally, how do I serve? So serving is the traditional ML ops. Now we are calling LLM ops. So whenever you deploy a new LLM, you want to do evaluations and you want to run a lot of tests, and then only when it passes through that, you want to put that. And then you should be able to serve multiple models, and they will have to coexist. And then you will have to optimize the number of GPUs you have. You are running a cluster, and then how you are bringing up pods, and then how the pods are communicating with each other to optimize the serving, all of that. And then finally, optimization of the GPU itself. There are concepts like taking a GPU and creating virtual GPUs out of that. There may be a larger GPU, you must split that. For example, an H100 is equivalent of around 3.5 A100s. So you can actually split that. So software allows that. How do you do that? Then a lot of, when it comes to the application development, there is a very important part, prompt engineering. So prompt engineering has become so important that it is like Excel skill. We all need to learn, right? So as part of our ramping up, I ensured that everyone, including my Scrum Master, go through the prompt engineering. So this is what really drives most of your orchestration and the generation also. But there are challenges. The challenges are each LLM has a different prompt template. So how do you support the prompt template? You need to dynamically pick up the right prompt based on the LLM you are sending the request to. And then prompts, by changing a few words, you are changing the complete process itself, the response itself. So what developers do is they continuously test various prompts. For example, I want it to also introspect and also look for other sources, right? I wrote in English and then I changed it slightly. So I have now 2 versions. So I want to test which one is performing better and choose the better performing one. That is where the versioning and then complete prompt management comes in. How do we do that? And then finally, how do we allow developers to to quickly develop these applications? If they have templates, they can use the templates and quickly build that. And then if they have no code, low code tools for the business users, it's much easier for them to build. And then there are developers who are comfortable with Python, they are happy with Jupyter. For them, we'll have to provide. So this is really the functionality that we had to do. Now, I had to build it again using all open source. This is where my stack comes in. We converted that into a set of open source products. And in fact, these open source projects, they have been evolving. So when I started, some of them were the hottest. For example, we were originally running, when I took over this team was using Sheldon Core. So Sheldon Core recently launched at that time, Sheldon Core 2. So Sheldon Core 2 allowed LLMs also. A few months into the project, Sheldon Core changed the licensing. So except for ML server, rest of the stack, they changed it to a different restricted license. So I had to again switch. So there are a lot of those things that happened. So it evolved. So over the past 1.5 years, I had to drop a lot of components in my stack. For example, let me start with again the data pipelines. We initially built our own chunking software. And so that was because almost every GenAI project, your management will ask you to quickly create a copilot, okay, using your documentation. When we were doing that, we are mostly an on-prem appliances company. Right? So they're the storage company where we have multiple versions of documents. And these documentation, each version, the documentation team used different tool, or over the years, they use different formats. So both HTML and PDF, they don't fit in. So a single tool doesn't work. So to somehow extract text and then create chunks and then create embeddings out of that, we wrote our own custom tool. So a few months into that, we realized that we can't maintain it because we have a lot of other functionality to develop. We started evaluating. So we took Unstructured.io. I'm not reading through everything. So these are some of the decisions I had to take. So for our messaging system, we were using earlier Kafka. Kafka and Knative eventing was what we were mostly using. However, since we have very limited compute power on this appliance, for our use cases, we had to again take some decision. So we had to switch to RabbitMQ, and then we use Celery to do the distributed task management. So Celery and RabbitMQ together allow us to run these data pipelines at scale. Basically, loading the unstructured documents, creating chunks, and then creating embeddings. We use Quadrant as our vector database. And then I'll come to the the data access. So data access is where we created our own lakehouse. So again, lakehouse is too big a word. What we did was to create a lightweight data fabric using data fusion. So we also call it FDAP. FDAP is your flight, data fusion, Arrow, and Parquet. So we chose Parquet because that provides us very good compression. again with columnar, and then the high performance query. Data Fusion is a proven query engine. We use that, and then we modified it a little bit. We wrote some additional layers on top of it to provide access to, say, S3 buckets, so from within this layer. And then to run the distributed queries, we adopted Apache Ballista. Apache Ballista is not mature, so we took that and then we enhanced a little bit. I'm going to talk a little bit about that later. So, so then orchestration. Orchestration, the tools have been, the frameworks have been evolving. So I started with LangChain. Later, midway through that, we started seeing that, oh, Llama Index providing certain features in certain functionality. So then we realized that we can actually mix and match. Both of them can coexist. Then we started using LangGraph. LangGraph provides us the ability to control the flow and have the context and then keep memory. Memory is a very interesting concept. So I'm not getting into the details, but we'll discuss. I'm here after this session. If anyone is interested, we will discuss. So then how do we build? And then agentic RAG. Agentic RAG, last year also, there was a lot of hype about agentic RAG. We burnt our fingers at that time. It was not mature. So because the LLMs themselves were not mature enough, for example, most of the open source LLMs at that time didn't have function calling capability. Without that, you can't do most of the tool execution. If you can't do tool execution, agents don't work. And then agents themselves, the frameworks themselves were not mature. We evaluated various frameworks. We evaluated Crew AI. We used, we evaluated AutoGen. We evaluated LangChain's own agent framework. We also evaluated semantic kernel. Finally, we settled on creating our own stuff along with using LangChain and a little bit of LangGraph. So I have 10 minutes. Okay. So let me complete the rest of the things. And then coming to MLOps, we standardized on Kser with Knative. So there is a small addition I need to make. So initially we were using the runtime as VLLM and various others. So a Selden Core ML server also we were using. Later, once we tied up with NVIDIA, we are getting very good support because they are partner. So we switched to Triton Inference Server. Triton Inference Server allows you to serve both ML models as well as LLM models. Before that, I had to use different runtimes to run different types of models. So we standardized on that. And we also use Knative. This is some innovation that we made around. So Knative serving we used. So some of the orchestration we bundle as a function. This is a very interesting innovation our team delivered. So where you take a flow, orchestration flow, and run it as a function. That gives us a flexibility to invoke this orchestration flow both as an API as well as event-driven system using Knative eventing. Now, prompt management. We used Agenta. Agenta allows you to manage the prompts. So you can define the prompt templates. You can have different prompts and then evaluate how these prompts are performing side by side. You can run evaluations, and then whichever is good, you can promote it to the production. And then Ragas. Ragas is a framework to evaluate your RAG systems. So you have retrieval augmented generation metrics. For example, what is the quality of the context? You're generating the context. Is it relevant? And then what is the recall? So is it picking up the right chunks from your semantic search? Those kinds of metrics are there. So Ragas allows you to run these metrics, these evaluations against your RAG. And then similarly for your agent flows also, is the agent picking up the right tool? So how do you evaluate? To do that, Ragas allows you, provides you the evaluation framework. So we standardize on that. And then developer tools. So developer tools, we evaluated Flowwise and Langflow. So we finally settled with the Langflow. Again, there's not much difference between them, but since we were comfortable quickly developing those custom components with Langflow, we took that. Our developers, so the data science side, they use Jupyter Lab. We just bundled it. But today, most of our use is with Langflow and our own tool. So I have not yet spoken about our own tool because this is an open source event. We wrote our own tool as well. It's a no-code tool with anyone can quickly with clicks can build that. Even there we used open source, that is React Flow. Now let me convert this into a stack because we are all comfortable with stacks. So On the left side, you have developer tools. Developer tools, we divided into three parts, kinds of persona. One is no-code tools for any business user to be able to create these apps with clicks. And then the next one is low-code with drag and drop, then code tools. And then you have all the serving part, whether it is the infrastructure itself. So this is completely it runs on Kubernetes. And then we have this whole thing runs on the hardware on-prem. However, this is also completely tested on cloud. Again, as I said, we are a hybrid company. So we also run the complete suite also runs on Azure. In fact, we can run it on anywhere. So then on the right side, you have the common services, DevOps. In fact, we use Argo, and then observability. We did a lot of work around observability, but for us, since it is a constrained environment, we again use FDAP stack with data fusion and all. So let me get into that to explain that. So this is really our stack. So wherever you see these red icons, there are Hitachi data editions. So these are our tools. But even there, we use open source. For example, this is React Flow. And then we created our own agentic tooling for agentic RAG. And then we created some templates. One of them is knowledge. We call it knowledge skill, using which you can quickly create a document RAG. And then you have observability copilot, another one. I think I'm running out of it. Yeah. And then we created a data fabric, again, using FDAP. We use Minayo as our S3 layer. So I'm seeing. So then GrepTimeDB. So this is where I would like to quickly expand. So GrepTimeDB, we initially started using OpenObserver because I wanted a very lightweight observability solution, a single solution to handle my metrics, logs, traces. So for that, we started with OpenObserver, but because OpenObserver also uses data fusion, which is our query engine. But later, OpenObserver changed their licensing model. So we had to again go back. We are not allowed to use AGPL. AGPL, we consider that as a toxic one, especially the enterprises, they don't allow that. So I had to switch to GrepTimeDB. We standardized on observability. Now, our entire stack, it uses Kubernetes. So Istio is an important part. We had to make some enhancements. For example, OAuth to proxy, we had to make it multi-tenant. And then our serving itself, we had to make some changes to our serving model itself, Kserve itself. So our models, most of the models are Meta, Mixtral, and BAI is Beijing Academy of Artificial Intelligence. They have very nice embedding models. We use that. Nexus is another player where they make a very specialized function calling LLMs. So we use a bunch of different models. Rest of them, in the interest of time, I'm not getting into that. To quickly tell our one of the sample apps built using our platform. So this is a very simple observability companion. Copilots we internally call companions. So this here, if you see, using simple English language, you ask a question. It may look simple, but behind the scenes a lot happens. So it needs to do metadata query. It needs to query the actual observability data, and then it needs to form the queries and then to execute that. And it needs to use the capabilities to create even the visualizations. So this is completely done using this platform and using open source LLMs. We didn't use OpenAI, we didn't use Anthropic. It is completely driven by your Llama 3s, recently Llama 3.1, and then we used Nexus 11, we used BGEM. So it's completely open source. Now, our enhancements, OAuth to proxy, we enhanced. Langflow, the ability to run on serverless environment, converting that into a function. And then we are enhancing GrepTimeDB. So GrepTimeDB uses etcd. From there, we are moving to Postgres. And then Agenta. So Agenta, we see it didn't support Kubernetes. We are doing that. Then there is more in the pipeline. Self-service model of deployment. Any developer should be able to deploy a model. Right now, we don't allow that. So it goes through our ML ops team. You need to create a ticket. You need to tell which model, so they'll take care. But I want to take it to the self-service model. Guardrails. So guardrails, I'm not expanding that. So putting controls on what it generates, I need to still make it customizable. Right now, it is a brittle integration. I need to do that. And Agent Studio, how do we quickly build agents? So this is what we would like to do that. Now, some quick thoughts. If you are building GenAI apps, go for quick wins. So something that you can quickly you can show to your management. So in our case, we created a very simple co-pilot, and in fact, we made the CFO's office, one person in CFO's office to create that co-pilot using our tools. They created on their own lake house, and then they were able to converse in English with their data. So that is a quick win because they are the decision maker. We need budgets. When I say budget, it's not just dollars. You also need your reservation of GPUs or your GPU budgets, etc. So all of that. And tech stacks are like fashion trends. Don't get attached to that. We dropped a lot of things. So we dropped, for example, Tika, Apache Tika we were using at one point. We dropped it. We switched to unstructured. And because of our requirements, I had to drop Kafka. So, and then finally, don't be a code hoarder. This is a very common thing. We get attached to the code that we write. Don't do that. So be ready to drop because the stack is continuously changing and it is also part of your learning and your growing up. Okay. With that, thank you very much. So I think I overshot. I don't know whether I have time for Q&A, but I'm here.
Thanks. We need the Q&A offline because